Hello, in this video we will be looking at complex fractions. A complex fraction is a fraction that's written as one fraction divided by another fraction. So it's basically the quotient of two fractions or two irrational expressions. So this is the quotient of two fractions. For example, a over b divided by g over h. Okay, so where a and b is fractions, and a and b is a fraction, g and h is a fraction. Or two rational expression, the quotient of two rational expression. So an example in this case would be, let's say, 1 over x plus 1 over y divided by 1 over x minus 1 over y. So it's just a fraction divided by a fraction. Now, you know how to divide or multiply or add any fraction or rational expression. Okay, if you're given this numerator by itself, you know how to add that. Or if you're giving this denominator by itself, you know how to subtract that. Okay, and after you finish simplifying numerator or the denominator, then you know how to divide. So this is just a process that we have to go through here in simplifying complex fractions. So let's look at an example. Yeah, example. If I ask you to simplify 3 over 4 divided by, and I'll make that division line a little bit longer and brighter, 5 over 8. So the first thing that we should look at is, can we simplify the numerator? 3 over 4, is it reducible? Yeah. And then look at the denominator. Can you reduce or simplify the denominator? Yeah. So what you can think of, we sort of did this before. Look at the top, the numerator, and I'll refer to that as the top, which is 3 over 4, and simplify. And then we look at the bottom. Yeah. Look at the denominator, which is the bottom, and that's 5 over 8. Try to simplify this, or add or subtract, whatever you have to do. So notice here, there is no simplification. And same thing here, you cannot simplify 5 over 8. So what you will do is now rewrite the problem, okay, complete the problem using the division symbol. And I'm referring to that symbol there. So what do we have? We have 3 over 4 divided by, okay, and how do you know what's that division sign? Remember, when you look back at your problem, notice here that this bar is a little bit longer slash bold. Okay. So that's how you know what that division sign is. And we'll divide that by 5 over 8. Okay. Now recall that we have to change the division sign. So by doing this, we have 3 over 4 times, and don't forget, when you times, this here must flip. So it becomes 8 over 5. Okay. And now we look for a simplify. Simplify if possible. So you will notice that this number here is divisible by itself, and this number here is divisible by itself. So you can say 4 divided by 4 is 1, 8 divided by 4 is 2. Okay. So what we have now is 3 over 4 times 2 over 5. 3 over 1, sorry, because that was simplified. 4 divided by 4 is 1, and then a 2. And there is no other simplification, so we multiply. 3 times 2 is 6. 1 times 5 is 5. Okay. So here we got lucky because our work becomes less because there was no simplification for the numerator or the denominator. Okay. Now, if we look at our another example, and I ask you to simplify 1 over x plus 1 over y divided by 1 over x minus 1 over y. So what I do, I like to separate this so you don't be confused with this whole idea, right? And hence the word complex fraction. It looks very complicated right now. Yeah. So we take the top. Keep in mind, when I say top, we're referring to the numerator. Yeah. The numerator is 1 over x plus 1 over y. And we take the bottom. Keep in mind, when I say bottom, we're referring to the denominator. Okay. And that is 1 over x minus 1 over y. And let's simplify slash add here. Yeah. So the lowest common denominator, remember what I said, we start off with this denominator, which is x. Then there's nothing there, we move along, so that's a y. So the lowest common denominator is xy. Okay. So if I say that the lowest common denominator is xy, notice in this denominator, I have to multiply that by a y. So I will have to multiply the top by y. Because if you multiply here by y, you have to multiply there by y. If you look at the next term, here we only have a y. So we have to multiply the top and bottom by x. So this becomes plus 1 times x. Well, 1 times y is just y. 1 times x is just x, so plus x over xy. So we're able to write the numerator as one fraction. Okay. Now, if we do the same thing for the bottom, the lowest common denominator will be xy, and if I write the common denominator as xy, and then you look at this denominator, we only have x. So that means I have to multiply by y, and I have to multiply the top by y. So this becomes 1y, and then minus, and then I do the same thing. If I look at this denominator here, I have a y, so I have to multiply that by x. So my numerator here will be 1 times x. And then if I multiply this, 1 times y is y, minus 1 times x is minus x over xy. So once again, here we have one fraction. Before we had two fractions, right? One minus another. Okay. So I will now rewrite the problem. And we now have y plus x over xy divided by, okay, because remember, this line here means divide, okay, divided by y minus x over xy. And remember, we have to change the division sign, okay, change the division sign. And flip. So what we have is y plus x over xy times xy, remember we have to flip, divided by y minus x. And here we can simplify. Okay, simplify. So you'll notice that this will cancel with that. We cannot cancel these two terms because this is a plus and that's a minus. So we're left with y plus x over y minus x. And this is our final answer. If we look at another example, simplify. We have x minus 2 over x squared minus 9 divided by x squared minus 4 over x plus 3. So here is my top, the numerator, and here is my bottom, the denominator. So let's take out the top. Let's take out the bottom. So we have x minus 2 over x squared minus 9. And then in the bottom we have x squared minus 4 over x plus 3. Well, can we do anything here with this? It's written as one fraction already, so that's good. But we can probably factor the denominator as x minus 3, because it is difference of squares, times x plus 3. And even if we do this, nothing really cancels. Okay. And then if we look at the bottom, it's already written as one fraction, but notice we can still factor the top because it's difference of squares again. So we have x minus 2 times x plus 2. And that is divided by x plus 3. So now I can rewrite my problem using the division symbol. So we have x minus 2 over x minus 3 times x plus 3 divided by x minus 2 times x plus 2 over x plus 3. And don't forget, we have to change that sign, okay? Change the division sign. Flip. So we have x minus 2 divided by x minus 3 times x plus 3 times x plus 3 divided by, because remember we have to flip this fraction, over x minus 2, let's get rid of that, times x plus 2. And now we look to see if we can simplify. So you will notice that x minus 2 here cancels with the x minus 2 there. You will also notice that the x plus 3 here cancels with the x plus 3 there. And there is nothing at the top to cancel anything from the bottom. So we're left with 1, because you can't leave the top empty, x minus 3 times 1 over x plus 2. Now you could write it in parentheses, or you could leave it out, doesn't matter. And now we multiply, 1 times 1 becomes 1 over x minus 3 times x plus 2. And as I said before, there is no need to multiply this out. But if you want, you can multiply. Okay, you can multiply it out. So here's our answer for this simplification. Okay, that's our answer. Let's look at another example. Simplify. So we have 1 minus 9 over x squared divided by 1 minus 1 over x minus 6 over x squared. So remember, don't make them look or scare you, right? We're going to separate it. Here we have the top, and here we have the bottom. Let's work them out individually. So if we take out the top, which is the numerator, we have 1 minus 9 over x squared. If we take out the bottom, we have 1 minus 1 over x minus 6 over x squared. So this here as a fraction is 1 over 1 minus 9 over x squared. So the common denominator here is, start off here, there's nothing to factor in the denominator. So 1 times x squared, okay, which is really equal to x squared. So if I write my common denominator as x squared, so you'll notice that here I'm multiplying this by x squared, so I have to multiply the top by x squared. So this becomes 1 times x squared minus, now if you look at the next denominator, okay, it is already x squared, so all I'm doing is multiplying really by 1. So that becomes a minus 9 times 1. So if we now distribute, 1 times x squared is x squared, minus 9 times 1 is minus 9 over x squared. Okay. Now you'll notice that this here can be factored. Okay. So this is the same as x squared x minus 3, difference of squares, and x plus 3 over x squared. Now if I was just adding this, I would leave this as the answer, right? I would leave this as my answer. But since I know I have to divide this, I'm factoring the top. Now if I look at the bottom part of the fraction. So once again, this 1 here as a fraction is 1 over 1 minus 1 over x minus 6 over x squared. So what is the common denominator here? The common denominator. Now keep in mind x squared is the same as x times x, right? So we'll start off with the 1 times x. And I don't want to say times x, right? Because we already have 1x here, so we don't need a repeated one there. So the common denominator is really 1 times x squared. Yeah? X times x becomes x squared. Remember we said before that we don't write them repeated times, okay? So my common denominator is 1 times x squared, which is just x squared, right? So let's look at each fractions. So you notice that this fraction here, I have to multiply the top and bottom by x squared. So I multiply here by x squared, I'll have to multiply the top by x squared. So that becomes 1 times x squared minus, if you look at this fraction here, I'll have to multiply the bottom by x to get an x squared, therefore I have to multiply the top by x. So this becomes 1 times x minus this denominator here is already x squared. My common denominator is also x squared, so I'm just multiplying that top and bottom by a 1, right? So now we have 6 times 1. Now, if we multiply, 1 times x squared becomes x squared, minus 1 times x becomes minus x, and 6 times 1 becomes minus 6 times 1 becomes minus 6 over x squared. Now, like I said, if I was just adding or subtracting, I would leave that as the answer. Okay, I would leave this as the answer. But because I know I have to divide, I'm going to factor the top. So by factoring the top, I get x minus 3 times x plus 2 over x squared. Now I can rewrite the problem. Okay, rewrite the problem using the division symbol. So we have x minus 3 times x plus 3 over x squared divided by, okay, x minus 3 x plus 2 over x squared. Okay, that's my division, because I know I had a division symbol here, right? The darker line always tells the division. Now, we have to change my division to multiplication. So this becomes x minus 3 times x plus 3 over x squared times, and don't forget I have to flip. So we have x squared over x minus 3 times x plus 2. Now we simplify. So if we look at this carefully, there's an x minus 3 in the top and an x minus 3 in the bottom. There's an x plus 3 in the top, but there's no x plus 3 in the bottom, so that stays. There's an x plus 2 in the x squared in the top, sorry. There's an x squared in the top, and there's an x squared in the bottom. And there's nothing else that's alike in the top and the bottom. So what do we have left? We have x plus 3 over 1 times 1 over x plus 2. And now if we multiply, x plus 3 times 1 is just x plus 3, and 1 times x plus 2 is x plus 2. So here is the simplified result. Okay. So I think, and you don't have to split it the way I split it, but once you take out the bottom and the top and you work with them separately, it looks less confusing in my opinion. Okay. And you're able to see what you're doing, especially if you mastered addition, subtraction of rational expressions, or multiplication and division. So you're kind of separating into problems here, smaller problems. Let's look at the last example. So this one here, example, simplify. This one here, I'll give you 2 of them to simplify. So we have 2 minus 3 over x plus 1/3. Okay. So notice you have 2 fractions. We have 1 fraction minus another fraction. Okay, 2 fractions you have. But the one to the right seems to be more complex, right? So this is the same as 2 over 1 minus 3 over x plus 1/3. So let's see if we can simplify this fraction, this complex fraction. Okay, this one is complex. So if we look at the top, okay, the top and the bottom, top is just 3, and the bottom of x plus 1 over 3. So there's nothing here to simplify, okay? Cannot simplify. It's already in its simplest form. It's 3 over 1. Doesn't matter. But on this part here, okay, this is can written as this one here is x over 1 plus 1 over 3. So we have a common denominator of 3. And if my common denominator is 3, it means that for this fraction, I have to multiply the top and the bottom by 3. So this becomes x times 3 plus, if you look at this fraction, the common denominator is already 3, so all I'm doing is multiplying the top and bottom by 1. So we have 1 times 1. Okay. Now when we distribute, x times 3 is 3x. 1 plus 1, 1 times 1 is plus 1 over 3. So my problem can be rewritten as 2 over 1, okay, was minus 3 over 3x plus 1 over 3. Now keep in mind, right, that I still can simplify this because just that portion really means 3, okay, divided by 3x plus 1 over 3. Now we said that 3 can be written as 3 over 1. So this is 3 over 1, 3 over 1 times, and we flip this fraction, 3 over 3x plus 1. And there's no like terms in the top or the bottom, so now we multiply 3 times 3, that's 9. And 1 times that term is 3x plus 1. So we have 2 over 1 now, 2 over 1 minus 9 over 3x plus 1. And we know how to add or subtract these things. We cannot add or subtract them unless we have common denominator. So our common denominator, this is already in its simple form, and this is in its simple form. So we have 1 times 3x plus 1. So that's my common denominator now. If you look in the first denominator, I am multiplying that by 3x plus 1. So I must multiply the top by 3x plus 1. So we have 2 times 3x plus 1 minus, if you look in the second denominator here, that is already the same as the common denominator. So all I'm doing is multiplying that by a 1. So this becomes 9 times 1. So, I mean, here we're doing things because there was 2 fractions, okay? We had to subtract 2 fractions. So first we simplify this complex fraction. And now what we're doing, we're adding the 2 fractions together. Okay? So if we distribute the 2, we have 2 times 3x and then 2 times a positive 1. So that becomes 6x plus 2, and then minus 9 times 1 is minus 9 over 3x plus 1. We do have some like terms, plus 2 minus 9. So here we have 6x minus 7 over 3x plus 1. And I think we're almost finished, but remember, you should always check for simplification. So this top, there is nothing to factor, right? There's nothing to factor here. There's nothing common between the 6 and the 7. And in the bottom, there's also nothing to factor there. So our final answer is 6x minus 7 over 3x plus 1. Okay? Final result. And this is my final answer. So this one here was a longer process because after I simplified my complex fraction, okay, after I simplified the complex part, I had to end up subtracting two fractions. So the first step was to simplify what I've highlighted there in green, which is the complex, so the top and the bottom. And then once I did that, I subtract the two fractions. Okay. So we're really bringing together what we have learned in the past. We learned how to reduce, we've learned how to add, we've learned how to subtract, we've learned how to multiply and divide, and that this problem tests us or tests your skills on all of those, right? We have to simplify, we had to subtract, we had to add, we have to multiply. So this is a very nice problem. And as always, at the end of my videos, I say the only way to become better at this is to always try additional problems on your own. With that being said, I will see you in my next video.